Hi, how's it going? Welcome to Code with Z. In today's video, we have to implement min_stack. Why? Well, because that's what LeetCode 155 min_stack is asking us to do. As you can see, it says, design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So you basically have to implement a stack. However, we also have to keep track of the minimum value, and we have to do all of this in constant time, which is really easy. Don't worry about it. As you can see, we only have to implement these. Min_stack is basically the initialization of our stack, and then push, pop, top. So push and pop are self-explanatory. Push is pushing an element inside of our stack. Pop is popping an element from our stack, and top is just basically returning the top value in our stack, and you're just going to see all of these in the visualization. Don't worry about it. And get minimum is also self-explanatory. It will return the minimum value. Now let's see how we can solve this. So these are our requests, and I've actually come up with an example. So for example, instead of just saying push, I have push -2, and we're going to implement these with visualization. So let's start. The first step is actually initializing our min_stack. Well, a stack is just basically an array. So we're just going to define an array and we're just going to call it stack. However, because we need to keep track of our minimum value, we're going to have another stack. So we basically have two stacks. We have stack and min_stack. Stack is going to keep track of all of the numbers that we're going to push to it, and min_stack is going to keep track of the minimum values that we have inside of this stack over here. And we only have two simple rules for our min_stack. We're going to say anytime when we have a pushing procedure, we're going to say if the min_stack is empty, or if the value that we're currently pushing into our stack is less or equal to the current minimum, we also want to push that inside of our min_stack. Now don't worry if something is foggy, because we're going to have a visualization. And then the final rule is going to be, once we pop from our stack, we're going to check if the pop value is actually the minimum one. If it is the current minimum, we also have to pop that value from our min_stack. Now let's start the visualization. As you can see, it says push -2. Well, we're going to push -2 inside of our stack like so. And then we're going to check our rules for our min_stack. We had a push, so we're going to check this one. We're going to say if the min_stack is empty, well, it is empty. If it is empty, we're not going to check the OR because we already know this is already true. Push the value to min_stack. Push the value to min_stack. All right. And then we're going to have push 0. So let's push 0 inside of our stack. And then we're going to check again. We had push. So we're going to check this rule. We're going to say if the min_stack is empty, it's not. Or if the value that we currently have is less than or equal to the current minimum. Well, the current minimum is -2 and our current value is 0. This value that we have here is smaller than 0. So we're not going to push it inside of our min_stack. And then we have push -3. Well, again, we push it to our stack and then check the rules for our min_stack. We're going to say if the min_stack is empty, it's not, or if the current value, which is -3, is less than or equal to the current minimum. Current minimum is -2, -3 is smaller than -2, so we're going to push it here as well. Now, the minimum is -3, and then we're going to have get min. Once we call this function, getMin is just going to return the last element that we have inside our min_stack. So when getMin is called, we're going to return this -3 that we have here, like so. And after that, we're going to have a pop. We're going to pop the last value inside of our stack because that's how stacks work. When this gets called, we're going to pop this. And then because we had a pop, we're going to check the rule for our min_stack. It says if the popped value is the same as the current minimum, meaning the top of our min_stack, well, yeah, it is, because the value that we popped was -3 and the top value in our min_stack is also -3. If that's the case, pop the value from the min_stack as well. Well, that's it. And then we're going to have a top, and top is just basically going to return the top element inside of our stack. Top is going to be 0, and then we're just going to return it like so. And then we're going to get min again. Get min is going to be basically returning the top element in our min_stack. Currently it is -2, so we're just going to return -2. And that's going to be it. Simple as that. Now let's code this in the simplest way possible. Alrighty, let's code this together. So as you can see, this is how we're going to implement it. This is how the question is structured. For example, we have top, we have get min, and each time we're just going to implement the logics that we have here for each one. So in the beginning, we have to initialize it. And this is going to be really simple. We're just going to say this dot stack is equal to an empty array, because stack is just an empty array. And we need this, basically this, in JavaScript. But we also need to have another stack, and that's called min stack. So we're gonna say this dot min stack is also equal to an empty array. So this one is basically done, as you can see. And then we have to implement the push function. Well, for pushing, we're just gonna say this dot stack dot push, and we're just gonna push the value that we are given. But we also have to check the rule that we had for our min stack. We're gonna say if this dot min stack dot length is equal to 0, meaning if it is empty, let me drag this to the left a little bit, yep, better, or if the current value is smaller or equal to the last element inside of our min stack. So we're going to say this dot min stack, last element, so this dot min stack dot length minus 1. So if the current value is smaller or equal to the last element inside of our min stack, basically what we had in the slides as well, we're just gonna say this dot min stack dot push of that value as well. So now our push function is also done. So we're basically done with this one as well. So let's go to pop. For popping, it's gonna be a simple pop. So this dot stack dot pop, and that's gonna be it. But we wanna store this value that we have here. So we're gonna say const last element, like so. And the reason we want to keep the value that we pop is because we want to check if it was the minimum value or not. Because if we remove or pop the minimum value, we need to also update our minimum value, right? So we're going to say if last element is equal to the last element inside of our min stack. So this dot min stack dot length minus 1. If it is equal to the last element inside of our min stack, we want to pop from our min stack as well. So pop. Simple as that. Now popping is also done. For top, we're just going to return the top value inside of our stack. So stack this dot stack dot length minus 1, the top element inside of our stack. Top is done. Now let's go to get min, and this is going to be really simple. We're just going to return the last element inside of our min stack. So we're going to say return this dot min stack of min stack dot length minus 1. Simple as that. And that's going to be it. Let me zoom out a little bit, like so. So you can see them, like so. As you can see, this is going to be it. I hope I have not made any typos. Let's run this and see if we can actually get accepted. And yep, awesome. Now let's submit this and see if we can actually pass all of the test cases. And yep, we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.